Hi, I'd like to present to you a study with the title of An Application of Machine Learning in Financial Distress Prediction Cases in Indonesia, done by author Thea Oribel and Dewi Hanggraini. There's going to be four topics to be discussed. The first one is background, second is literature review, the third one is method, and the fourth one is discussion. First, on the background of the problems, for many years, professionals are trying to detect the potential of failure in business in order to reduce the impact caused by bankruptcy. The failure of the business itself is generally preceded by financial distress, which can be concluded through the company's performance in the previous years. And for this reason, predicting financial distress has been a very relevant topic among practitioners and researchers for years now. And so, up until now, there are numbers of studies regarding this topic. One of the most popular metrics to predict financial distress is by Altman, formula founded in the 1968. Although many have used Altman's formula in determining financial distress, numerous local studies in Indonesia found that Altman financial distress predictive model has produced low accuracy when applied on the local companies. This finding implied the importance of contextual factor in financial distress prediction, which means a similar financial distress predictive formula may work far differently in a different context, and in this case, Indonesia's companies. On the other hand, there are several critics to the conventional distress formulas. One of it pointed out the overfeeding and underfeeding bias, which was likely to happen in the past researches. This caused a low accuracy when performed on a different data set. Now, additionally, most of traditional statistics failed to capture the multidimensional nature of the failure. Now, due to these reasons, newer studies recommend applying advanced statistical methods such as applying machine learning on financial distress problems. Next slide. Recent studies using machine learning method widely carried out in other countries have produced a higher level of accuracy. In line with these arguments, this study will apply machine learning method, specifically SVM, which is support vector machine, in effort to build a financial distress predictive model for Indonesian companies. On the second one, literature review. Again, the failure of the business itself is generally preceded by financial distress, which can be concluded through the company's performance in the previous years. There are some popular financial distress and business failure prediction models. For example, Altman's Z-score, Olson's model, Springate model, Zmijewski's model. Here in this research, we will take the financial ratios used in this formula as our independent variables. To define which company will be categorized as financially distressed, we will use Altman's definition financial distress in his research in 2007, which is companies experiencing financial distress are companies that have negative cumulative earnings for 2 consecutive years, or have a NAV, which is net asset value, below par value. Next. For further context, machine learning is a scientific area that utilizes computational algorithms to summarize empirical data into a model. And as for SVM, again, support vector machine, it is a machine learning algorithm that has the advantage of being able to work on small, nonlinear samples and high-dimensional pattern recognition of data through utilizing the function fitting feature. Now, in support factor machine, the high dimensionality is identified by testing spatial data dimension assumption, which are linear, polynomial, and radial assumptions. And these assumptions follows the mathematical functions to find the best accuracy and determine its dimensionality type. Function fitting feature in SVM utilizes the computational power to do a cross-validation and find the best C and gamma parameters for the model. The C and gamma parameter are also used in are useful in avoiding overfitting and underfitting bias, as shown in the corner right graph, which often happens in ordinary regressions. This feature will also be performed in this study. Now, the third topic is the method, the variables and the methods used. In terms of variables, this study will use 30 financial ratios as the independent variables, as listed in the table. These independent variables are collected from the past studies. And for this study, the dependent variable will be FD, or financial distress. Moving on, in terms of data, right? This study will use non-financial companies which are listed in Indonesia Stock Exchange from 2010 to 2019. The company will be split into two groups equally. The first one being financial distress companies and the second one being non-financially distressed companies. On top of that, this study also applies testing training split with the ratio of 80% for training and 20% for testing to determine whether the model can work on different set of data and whether it can provide a high level accuracy. Now, in total, 3,110 companies were studied. Also, based on the categorical definition earlier, about 200 financial distress cases were identified. As a result, 420 matching samples data will be used to build the model. After the data is collected, the data is then separated for the process of testing and training, or testing and training process, in other words. The 30 ratios are also reduced using t-stats evaluation, multicollinearity test, and normality test, resulting in 19 significant ratios to be tested to the DV, dependent variables, which again in this case is financial distress. Lastly, there will be 3 SVM model built for comparison in this study. The accuracy of each model and conventional formula is then compared to each other based on the same testing sample. Now, the last section of this study, the discussion and the results. From this table, SVM with linear and RBF kernels indicates that the highest performance among all of the models. All three SVM models consistently have higher values than conventional formula. This finding is aligned with previous studies where SVM outperforms other statistical methods. The SVM RBF model has the highest accuracy rate, which indicates the multidimensionality characteristic of the sample. This is one of the reasons for SVM to produce better accuracy than the traditional version of the usage of conventional linear statistic assumptions. Now, other factors that contribute to a higher accuracy rate for SVM models in this study compared to other models is that the conventional formulas from past studies mainly use default linear assumptions, whereas from this experiment with the grid search feature, the C linear parameter can be optimized and fitted to the model characteristics. This results clearly shows that the studies by Altman, Olson, Springate, and Zmijewski's towards the financial distress or bankruptcy prediction model do not have a high accuracy result when applied to Indonesia's companies. The number may be due to the different characteristics of the companies in a country where the experiments is conducted, different from the origin of this formula, where it was first constructed. Another reason could be because of the different characteristics of the companies relative to the time period of the research. And so, through this experiment, it is known that the SVM machine learning method is proven to produce a better model which has 90% accuracy in contrast to conventional formula which produce no higher than 70% rate of accuracy. The low accuracy in conventional formulas is because of the difference in period of year of observation. And on top of that, the second one being the difference of the country's characteristics where the experiment is conducted. Other different reasons are open to be explored in future studies. In addition to that, from this study, it can also be concluded that there is an indication of multidimensionality in financial distress cases. This result can further be developed in the future, given the high possibility of technology advancement in building programs that can automate the prediction processes. That could also develop a real-time model connected to the financial database. Last but not least, for the further studies, it is recommended to 1. Test more variables, 2. Try different feature selections methods, 3. Build the selection model for different sectors. And that is all. Thank you.